All right, in this explainer, we're going to visually map out 3 common diseases. We're going to trace them from that very first spark all the way to the clinical symptoms you'll see in a patient. Think of this as us building a mental flowchart together so you can see exactly how one step leads to the next. Let's get right into it.
So how does a disease really kick off? It's almost never just one single event. It's usually a cascade, right? A chain reaction inside the body. And we're going to follow that chain. We'll look at how an initial trigger, maybe a hormonal imbalance, some misplaced issue, or even a virus, sets off a whole series of changes that eventually bubble up to the surface as symptoms.
So here's our game plan. First up, we'll break down the self-perpetuating hormonal loop of polycystic ovary syndrome. Then we'll dive into endometriosis, which is all about tissue ending upward shouldn't. And finally, we'll trace the viral takeover that can lead to cervical cancer. After that, we'll pull it all together for a quick review.
Okay, let's start with our first pathway, polycystic ovary syndrome, or PCOS. Now, the absolute best way to visualize this isn't as a straight line from A to B. Oh no. It's a vicious cycle where every single step just makes the next one worse.
The spark, the ground zero for this whole cycle, is something called a hyperandrogenic state. So what does that even mean? Well, in simple terms, the body is just making way too many androgens, like testosterone. And this one hormonal imbalance is the absolute core of the problem. It's the feature that drives literally everything else we're about to see with PCOS.
Now here's where it starts to get a little complicated. You've got this primary issue with androgen secretion, right? But it's not happening in a vacuum. It gets cranked up to 11 by other things like obesity and insulin resistance. It is literally like throwing gasoline on a fire. You take this underlying hormonal issue, and these other factors just make it explode.
So let's walk through exactly how this vicious cycle works. It all starts up in the brain when the pituitary gland starts pumping out too much luteinizing hormone, or LH. That high LH tells the ovaries, hey, make more androgens. This androgen excess then leads to insulin resistance and more abdominal fat. So what does the body do? It panics and pumps out even more insulin to compensate. That's hyperinsulinism. And here's the really cruel twist. All that extra insulin signals the ovaries to secrete even more androgens. And just like that, you're back at the beginning. The cycle just feeds itself, getting worse and worse with every single lap.
So what does this internal hormonal chaos actually look like for a patient? Well, this is what causes those classic exam-relevant symptoms. The high androgens mess with the menstrual cycle, causing anovulation, which just means the egg isn't released. That leads to irregular periods and, of course, infertility. At the same time, the excess androgens can also cause physical signs like hirsutism, which is that excess hair growth, while the messed up ovulation is what leads to those enlarged polycystic ovaries you'd see on an ultrasound.
All right, let's switch gears and move to our next condition. We're going to see a totally different kind of problem build up here. With endometriosis, the core issue isn't a hormonal cycle. It's tissue that is set up shop where it just doesn't belong.
The number one theory for how this happens is called retrograde menstruation. It sounds kind of complex, but the idea is actually pretty simple. Instead of all the menstrual fluid leaving the body, some of it flows backward, up through the fallopian tubes and into the pelvic cavity. And this fluid isn't just blood. It's carrying endometrial cells, which can then implant and start to grow on other organs.
And here it is. This is the central problem, the key to understanding the whole thing. This ectopic or misplaced tissue, it's still fully functional endometrial tissue. It thinks it's still safe and sound inside the uterus. So every month, when the hormonal signals for menstruation show up, this tissue does its job. It thickens, breaks down, and bleeds. But now it's bleeding directly into the pelvic cavity, where there's absolutely nowhere for it to go.
And this is where the real damage starts. That internal bleeding triggers a huge inflammatory response from the body. Month after month, cycle after cycle, this chronic inflammation leads to scarring and the formation of adhesions. These are literally bands of scar tissue that can glue organs together. As you can see, the disease progresses from these tiny little lesions in stage 1 all the way to thick, dense adhesions in stage 4 that can completely distort the anatomy of the pelvis.
So you can draw a direct line from that pathophysiology, that constant inflammation and those sticky adhesions, to the classic symptoms. The chronic inflammation causes chronic pelvic pain. Adhesions can cause dyspareunia, or painful intercourse, and dysgeusia, which is pain with bowel movements. And those same adhesions can physically block the fallopian tubes, which is a direct cause of infertility.
All right, on to our final pathway, which is a whole different ballgame. The process here isn't started by hormones or misplaced tissue. Nope, it's kicked off by an external invader, a virus that literally hijacks the body's own cells.
The spark for this cascade is a persistent infection with a high-risk type of human papillomavirus, or HPV. Now, it's important to know that most HPV infections are cleared by your immune system, no problem. But certain high-risk strains, like HPV 16 and 18, can sometimes stick around and start a really dangerous transformation at the cellular level.
This visual, it tells the entire story of this viral takeover. Over on the far left, you've got a normal, healthy cervix. But when a high-risk HPV strain infects those deep basal cells, it unleashes its own viral proteins, specifically E6 and E7. Think of these proteins as saboteurs. They go in and they mess with our body's natural tumor suppressor genes. This allows the infected cells to start growing out of control, progressing from a low-grade lesion to a high-grade one. And if it's left unchecked, those abnormal cells can eventually break through and become invasive cancer.
This brings up a super important clinical point. While HPV is necessary for the cancer to develop, it's not always enough on its own. Other factors can seriously increase the risk that the virus will stick around and cause damage. Things like behaviors that increase your exposure, and also factors that weaken the immune system's ability to fight off the virus, like smoking or being immunocompromised. Understanding these risk factors is absolutely key to prevention.
Okay, we've walked through 3 very, very different pathways to disease. Let's do a quick side-by-side comparison to really lock in how each of these works.
Here it is. This is your high-yield summary, your exam-ready cheat sheet. For PCOS, just remember that vicious cycle of androgens and insulin leading to menstrual problems. For endometriosis, it's all about that misplaced tissue causing inflammation and adhesions, which results in chronic pain. And for cervical cancer, it's that persistent HPV causing cellular changes that lead to cancer, with abnormal bleeding often showing up as a late sign.
And that really brings us to our final thought. Each of these cascades, they all have multiple steps, right? So the big question is, by understanding these precise pathways, the feedback loops, the inflammation, the viral takeovers, where can we best step in to stop the disease before it even fully develops? Now that is the real power of visualizing pathophysiology.